In this video, we're going to talk about some of the graphs of radical functions, and we just focus on square root functions and cube root functions. The steps you're going to want to follow I actually have just written out. If you want to graph a square root function as such, or a cube root function, all you're going to do is first sketch the graph of a square root of x or a cube root of x, depending on whether it's a square root or a cube root function. By the way, I call this this is going to be your parent function. Okay, and once you graph that, it's actually going to be easy. We're going to shift or translate the graph h units horizontally and k units vertically. This is the first time we've used this particular method to graph, so when you first see it, it's a little tricky, but once you get the hang of it, it actually gets pretty easy. For example 1. I want to graph y equals the square root of x minus 1 plus 2. By the way, in your homework and on a quiz, another alternative way I could perhaps write this would be y equals x minus 1 raised to the half power plus 2. Keep in mind, radical notation and that rational exponent notation might be used in one problem and not in the other. So just know that these would be the same and the steps would be the same. Part A, you're going to first sketch a graph of y equals the square root of x. What I mean by that is you're going to essentially ignore this other part and just graph what is the parent function, because that's a lot easier. This will always start at the origin. Let me see if I can spell that correctly. Origin, which kind of makes sense because if you were to just plug in, let's just make a quick table for this first one. If you were to plug in 0 for x, the square root of 0 gives you 0. That's the origin, guys, right? And if you plugged in 1 for x, the square root of 1 would give you 1. Let's do one more coordinate. I really should add, there's 1, 1, and another easy number to plug in that's a nice perfect square is 4. If you plug in 4 and take the square root, you'd get 2. So those are the three base coordinates that you're going to plot. Notice I did not try to plug in any negative values because I can't take the square root of a negative. It would be imaginary and there would be nowhere for me to plot it. So we're just going to plot these three coordinates, 0, 0, 1, 1, and 4, 2. So we would get 0, 0, 1, 1, and then go over 4 up 2. If I were to sketch the graph right now, I'm going to just dash this because this is not our final graph. The square root of x looks just like this. It starts at the origin and it goes up on a smooth curve through those points we just plotted. Now what we're going to do is we have to take a look back at what we originally had covered up, because now these numbers are going to impact us, okay? Now, in order to determine how many units we've shifted horizontally, what I need to know is what is my h value for this particular problem. Now, this is where you need to go back to, okay, the general format. I'm putting a box around right now. H is what is being subtracted from x in the radicand. So in this problem, the number that's being subtracted from x in the radicand is 1. So I know my h value equals 1. It's kind of like when we did our, the quadratic functions. You recall, guys, when we did like y equals a, and then we had x minus h squared plus k, that vertex form. Remember how the h value is always just the opposite number of what you saw? So it was positive hk for your vertex. It's very similar. The h value is going to be the opposite sign of the number you see, essentially, if you want to prefer it that way. So our h value is really equal to 1. Let me get rid of that question mark. It's really equal to 1. That means I'm going to shift all these coordinates 1 to the right. Okay, I'm going to shift 1 unit to the right. Now we also have to consider our k value. That's what we do when we shift vertically. So this has to do with what our k value is. Guys, the k value is what's being tacked on to the very end. So our k value in this case is just a positive 2. That means I'm going to shift vertically up 2 units. So this is kind of cool. What I'm going to do, let's use a different color. My final answer, if I take each of the existing coordinates, which the main coordinates I'm moving are this guy, and this guy, I'm going to take each of those and shift them 1 to the right and up 2. So if I go ahead and I take the coordinate at 0, 0 and I go to the right 1, and then up 2, my new and final coordinate is going to be this guy right there. That's my new starting point. All right. If we do the same exact thing to the coordinate at 1, 1 and go 1 to the right and 2 up, my final coordinate here is going to be at that point. The final coordinate we need to translate, 1 to the right and 2 up, is this original coordinate at 4, 2. So I'm going to go 1 to the right, 2 up, and my final coordinate here is as such. So my final answer, or my final graph I should say, starts at that coordinate from 0, 0 that was shifted over to, looks like it was at 1, 2, right? My new starting point's at 1, 2 from the original's origin. So my final graph just looks like this. And by the way, I know I'm going to ask you about the domain and range of your final answer, so let's take a look. Your domain has to do with your input values, right? So my domain, if you look at all of the possible x coordinates that are on my final graph, that purple graph, the lowest x value, remember domain has to do with x values, the lowest x value, think about it, starts down here at 1. Every other point on that graph has an x value that's larger than 1. So my domain would be all x values that are greater than or equal to 1. I don't have the ability to plug in an x value less than that. I start at 1. My range is all output values. Output values have to deal with y values, right? So if we looked at all possible y values here, think of all the y coordinates, guys. The lowest y coordinate I get starts here, and then all of these other points on my graph have y values larger than that point. That y coordinate there is at 2, right? Isn't that the coordinate 1, 2? So my y values are all greater than or equal to 2. It is impossible for you to find any point on my final graph that has a y coordinate that is less than 2. It just doesn't exist. Same thing with the x value. I don't have any x values that are less than 1. They're just not plotted. So this would be my domain and range. Let's take a look at another example. Okay, for this one. Oops, I'm looking at the same one. Let's do another one. That's what I want to see. For this guy, let's take a look at first our parent function. Now remember, when we do our parent function, we just want to only ignore that h and k business. So that's why my first graph is going to be of this guy right here. It's going to start at the origin. Again, if you want to make a table, you can, right? You're always welcome to. If you plug in 0 there and square root it and multiply it by -3, you'll still get 0 out. If you plugged in 1, I'll do my work here. That would be -3 times the square root of 1, which is just -3. So when you plug in 1, you get -3. If we were to plug in 4, which would be the next good x coordinate to square root, we get -3 times the square root of 4, which is -3 times 2, I would get -6. So when I plug in 4, I get -6. Let me write that here. Now, let's plot those points. I start at 0, 0. When we plugged in 1, we got -3 down here. And when we plugged in 4, we got -6. So let's see if we can plot that. Let's go 1, 2, 3, 4 down, 1, 2, 3, 4, 5, and 6 is right there. So we have these coordinates. What you might do, and you don't need to, our graph in general has this shape, right? This is our square root function. The reason why it's going down in this case, you might guess, is all having to do with that negative number in front, that -3. That's really what we call our A value. The leading coefficient is negative, and if it's negative, guys, your graph is going to go downwards instead of upwards. All right. Now we play the shift game, the same game we played on that first one. Let's reveal again the whole entire function and think of our h value here. The h value, again, is what is being subtracted from x in the radicand. In this case, it's positive 2. So h is positive 2. That means I'm going to go 2 to the right instead of just 1 to the right, like the last problem. And my k value, the k value is what's being tacked on the outside of the radicand. It's positive 1. So that means I'm just going to go 1 up. All right, so what I'm going to do is I'm going to take each of those coordinates and go 2 to the right and 1 up. And I'm going to make my final graph here. Let's use like a red. So I'm going to go 2 to the right and 1 up. So this original coordinate gets moved 2 to the right, 1 up to that spot at 2. This is the coordinate 2, 1, right? That's my new coordinate that I'm going to start with. If I do the same thing with this guy and go 2 to the right and 1 up, we would land here. If I take that third point we plot and go 2 to the right and 1 up, we would land here. So our final graph starts at 2, 1, goes down a nice smooth curve here. I'm going to show you another way of thinking of domain and range, okay? When we talk about domain again, we're looking at all the possible x values that we can plug into the function. So if I think about this, the lowest x value I have starts at 2 on the x-axis, and then they all go in that direction. So if you think about what we just highlighted, my domain, D, is all x values that are greater than or equal to 2. When I talk about my range, let's see if I can use maybe blue for range. My range has to do with y coordinates. Now, this starting point has my highest y value right there. All of my other y coordinates go down, right? Like any point on here has a y value that's less than that starting one, which was at 1. What I just highlighted here are all y values that are less than or equal to positive 1. So my range, all y values less than or equal to 1 is my domain and range. I'm going to show you one more example, and it's going to be of a cube root function. Here we go. Let's get started with this guy. Now, cube root functions are kind of interesting and a little bit easier in a way. We still go about graphing these much the same way we graph the other guys, and that's by graphing the parent function. I'm going to ignore all that stuff. And what that leaves me with is the parent y equals the cube root of x. Now we're going to plot a few more coordinates. Let's make a table for this one. If we were to plug in 0, the cube root of 0 is 0. So once again, it passes through the origin, 0, 0. And now we can plug in negatives because the cube root of -1 is a real number. It's -1. So it passes through -1, -1. And if we plugged in +1 and cube rooted, we get +1. I also like plugging in 2 more values. Another good x value to plug in that's a perfect cube is +8, and the cube root of 8 is 2. So if we plug in 8, we get 2. Oops, I forgot to fill out that coordinate 1, 1. This will give us the coordinate 8, 2. You can also cube root -8, which would give us -2. So we can plug in -8 and get out -2. Let's plot these coordinates. So if we start at the origin for our first guy, we have 0, 0, we have 1, 1, and -1, -1. We have those 3. Then we plugged in 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, and we got 2. And we plugged in -8 and got -2, which would be right there. The cube root function, if we just dash this one, remember, this isn't our final answer. If we just dash, it's kind of this S-shaped curve that snakes through the origin and just goes kind of across horizontally left to right. And it's always increasing. What we're going to do now is shift our graph by now taking into account our h and k values. In this problem, our h value is +2 again, which means 2 to the right we're going to head. and our k value is positive 1, which means 1 up. All right, I think you probably would recognize by now if our h value, let's just say for giggles, if the h value happened to be negative 4, and it's not in this case, right? Which direction do you think we're going to head? Are we going to go to the right or 4 to the right? No, we would go, because it's negative, this would be 4 to the left, just so you have a heads up with that if you see it on your self-quiz. K value, if your k value happened to be negative 1, you wouldn't go up 1, you would go down 1. Okay, so keep that in mind if your h and k's are negative. In this case, we're going 2 to the right and 1 up, though, so let's go ahead, and I'm going to move each of these points one at a time, 2 to the right and 1 up, starting with the origin. If I go 2 to the right and 1 up, that origin got moved over there. If I take this guy and go 2 to the right and 1 up, I'm now here. This guy, 2 to the right and 1 up, becomes that. All right. What you might even do once you get the hang of it, you might just erase those so we don't get like annoyed with them, right? And I still have a couple more points to move. I have to move this guy 2 to the right, 1 up to there. And I have to take this guy all the way back here, 2 to the right and 1 up, and land there. So my final answer, or graph rather, is this smooth S-shaped curve that goes through those coordinates. Your final domain and range is really easy for cube root function. If you think about it, there is no lowest x value that I'm allowed to plug in. The x values go all the way across your graph. So the domain is all reals, and that makes sense if you think about it. There is no domain issue, guys. When you have a cube root, right, you can plug anything you want. The range, very similarly, there is no lowest y value. The further to the left you go, the further down the graph eventually goes. And the same thing going to the right. The further to the right you go, the graph will gently climb up, up, and away. So we eventually get all reals for the range. And good news is any cube root function will always have this domain and range, making it a little bit easier for a quiz or a test. Guys, I think I have a nice set of problems for you to try for your self-quiz. The first one, you're trying to graph the square root function you're given, and then the second one is a nice cube root function. Do your best with that. I kind of have it set out, step by step, and we'll go over it tomorrow. Thanks for watching.